be seeing the rest of we will be seeing the rest of the preparation methods for alcohols and few more things like properties of alcohols and things like that. Okay, properties means what? Reactions given by alcohols. Make sure you are keeping your short note records. For organic chemistry, at least for organic chemistry, you should have this short notes. Number one. Number two, it should be continuously updated. Don't push it for tomorrow. You have to do it today itself. Otherwise, the best chance is that you easily forget it. Okay, because see, when you're even this time itself, when you are looking into your textbook, you look confused. You have a confusion where to start and where to stop, which is what, and sorting out is really confusing, isn't it? Am I correct? Sort of confusing. Am I right? But when you are keeping this short note, when I am giving these examples and reactions, please update it in your short note. You will have a ready reference with you. For organic, it is a must to have a ready reference. Okay, because it is your own handwritten one, you won't have to search all over because you know where you have written it. Even the page, the way you have written itself, you will remember. Am I correct? Okay, so that is the best method to learn organic chemistry. Organic chemistry is not something to mug up. Okay, most of us think so. Okay, it can be mugged up. No, it will only mug you. Okay, better learn it. Okay, one place something is getting prepared, another place it will be something else's property, chemical property. So, and the reverse reactions will be there. In one place it will be preparation of alcohol, other side it will be preparation of alkene from alcohol. Okay, so the reverse reactions, how it is done. All right. So how to go forward and how to go backward, what are the different reagents used, etc. It only comes from your short notes. Okay, so with this, we will start with our class today. I'm sharing the screen for preparation of alcohol. Just a moment. Yeah. Can you see the screen?
Loading.
Loading.
Yes.
No. The problem is I just closed it. Now,
Yes, ma'am.
okay. So from this area, preparation of alcohols, we have started with what? We have started
Not
with
the
the ink,
slideshow, mom. Okay.
not slideshow. Okay, just a moment. Yeah, now methods of preparation. Yeah. So the first method of preparation was the industrial method of preparation of alcohol, that is from what to what? From alkenes, that is hydration of alkenes. Then we were seeing the hydroboration oxidation method. Okay, so then we were going to see, we stopped that at that hydroboration oxidation, right? Hydroboration is where we stopped in our last class. Next method is, see, here is the answer for Neha's question. Actually, this H3O plus, this is the way it should be following. Okay, Neha. All right, the method is the same. Okay, method is the same. Finally, what happens is also almost the same. See, here it is. Oxygen is getting attached and cleavage is between what? Oxygen and hydrogen. Deprotonation is happening. Again, H3O plus is retained. Okay. So this is how the mechanism is proceeding. So no trouble. You are going to do the same thing every now and again. So commercially important alcohols are methanol and ethanol, wood spirit, that is methanol. Now it is from carbon monoxide and hydrogen. With the distillation of wood, they are preparing it. It is a poisonous liquid. Okay. So methanol is used in paints and varnishes. Can you all see the screen? This is simply that. That's it. Okay. Not much of a trouble. You don't have to take much of a trouble. Just note down the equation alone. Preparation of methanol. Okay, Amrita, but make it fast. Arpita, please turn your camera on. Okay, so once completed, please give me thumbs up, all of you. Because it is just the equation alone you have to take down. Why? Because chromium oxide and zinc oxide, that combination is a reagent we generally use for what? To catalyze this reaction. Arpita and Amrita, make it faster to turn your cameras on, because don't take too much time. Within a minute, you have to do it. Otherwise, I will have to remove you from the class. So now, completed, all of you? Just the equation alone you have to take down, nothing else. Okay. Take it down and we will move to the next. This is simply that point you have to note down. Completed, all of you? Anybody yet to complete? Please put on raise hand icon. Any raise hands? Okay, Karthik, continue. Yes, I can see Aditya, your thumbs up. Okay, Amrita and Arpita, I can see you. Neha, I guess you have completed. Okay, Sneha also, I guess you have completed. Good. Hari Siddharth, completed. Okay. Asmita, completed. Still writing. Okay. Naren, almost done. Okay. Arpita, still writing. Completed. Okay. Karthik, I guess you have completed also. Aditya, what happened? What is your doubt?
Ma'am, over here, would the wood be like carbon monoxide, ma'am?
Wood
Or
spirit, actually it is in controlled condition. They are smoking it. Okay. That's how it is
okay,
made.
so from there
Yeah.
the carbon monoxide is coming.
Yes,
From
exactly.
there. Okay,
Yeah.
thank you.
Good question. So ethanol, what is it? It is from fermentation. They are obtaining ethanol, alcohol. Okay. So the glucose, okay, not C6H12O6, not that. Okay, sucrose. Okay, sucrose molecules or the what you call long chain sugars are reduced using invertase and That will give you glucose and fructose. Okay. The glucose is then, in the presence of zymase, it is getting converted into alcohol. Okay. So first, the action of invertase, and the second, the action of zymase. This is the commercial production of ethanol. Okay, so whatever this wine making or breweries, all those breweries, distilleries, whatever it is. Okay, the principle is this. Okay,
Ma'am, in the second step, is it fructose that is being used or glucose?
it is glucose. It is from glucose. Okay. So ethanol, what is ethanol? See, both glucose and fructose is undergoing this reaction. That is my best guess. Okay. Not the only the what you call structure of glucose and fructose is different, but the way it is getting reduced is, I think it is the same. Okay, just colorless liquid, boiling point is only 351 Kelvin. Okay, and again, it is a very good solvent. Number of carbon compounds are made from ethanol. All right, you already have an idea about where and all properties of ethanol is coming up, isn't it? From ethanol you are making alkane. Okay,
Amines,
so many alkenes are
phthalates.
made, so many things are made from ethanol as a starting compound. Why? Because ethanol is easy to obtain. It is easy to obtain. Okay, that is one of the reason. It is cheap, it is economic. So that is it about this. So I think these two reactions is enough for you. Done. Okay. Now, MCQs. What is the first question?
Actually, could you show the previous slide once?
Yeah, just a moment. Here it is. Okay, all of you done? Any reasons here? Any reasons here? Because we are actually stepping into the Grignard. Yeah, Chandana, okay. The Grignard region part is one of the most important one. Okay, so we are going towards that side. Okay, Chandana. Done? Yeah, good. So now, just a moment, I will show you the slide once again. Before that, I have to turn on one more thing. And that will be a question. Can you see the screen? Okay. So what happens here? Here we are going to see about the other reactions, that is not this commercial method of preparation from these and all we have seen in the last class. From
Are you showing slideshow?
Reduction. Yeah. Can you see the screen now?
No.
Reduction or hydrogenation of carbonyl
No, no.
compounds? No.
It's like the height slideshow is not available.
Now, yeah.
Yes.
So reduction or hydrogenation of carbonyl compounds means what? When alcohol is oxidized, you are going to get aldehyde or ketone, which means what? Reduction should give the reverse, isn't it? Carbonyl compounds, that means aldehyde or ketone, when reduced, you should get what? Alcohols, isn't it? So alcohol, even further reduction will lead to the formation of alkene, alkane, etc. Alkanes mainly. But here we have to stop it at alcohol. So whatever reducing agent we are using is limited reduction. For this limited, it should stop at alcohol, not go further. Okay. So first method is what? For catalytic hydrogenation or nascent hydrogen release. Both methods can be used. Okay. Both method, catalytic hydrogenation or nascent hydrogen should be released. Okay, two methods are there. So this is the reduction one. First method, formaldehyde or formaldehyde or methanol. When they are reacting with hydrogen in the presence of Raney nickel, you straight away you get alcohol. Okay. There is no question at all. Straight away you are getting alcohol. You can see the white screen, I guess. No.
Yes,
White,
white screen.
visible. Yeah. So you are having HCHO. Okay. HCHO, when it is reacting with hydrogen in the presence of Raney nickel, H2Ni. This is the way it would be given in the question paper. Some 400 plus degree Kelvin. Okay, not degree. Okay, Kelvin. 400 plus Kelvin. Then in this temperature, you are having a conversion of methanol to methanol. Okay, formaldehyde to methanol or things like that. Again, there will be a confusion. Better take it in this way: methanol to methanol. Okay, so CH3OH, methanol is prepared. This is method number 1. What is the second one?
Nascent hydrogen.
Yeah, not nascent hydrogen, not that I mean. About getting ethanol, what should be used? What?
Ethanol.
Ethanol gives you ethanol. 413 Kelvin. Ethanol will give you ethanol. Okay. So next one, like this: CH3CHO giving H2 in presence of Raney nickel. Okay. 413 Kelvin. Here also it is 413 Kelvin. All right, you are getting CH3, CH2OH. Okay, means what? This carbonyl carbon, one of the hydrogen is getting attached here. Okay, turning this as OH plus. Okay, O plus. Now, this is getting shifted to this area. Like from carbon, the bond is shifting to oxygen. To that, hydride ion is getting attached. H2 is first split into H plus plus H minus. This H plus is getting attached to C double bond O, attacking oxygen, because oxygen is the only thing that is having an extra pair of electron. So coordinate bond. Okay, it will get attacked by oxygen. Okay, now there a bond is formed. Now oxygen is O plus, unstable. So carbon will have its bond shifted to the oxygen. So it will become C plus OH. Okay, now this plus charge is satisfied by the incoming hydride ion. This is how the mechanism is proceeding. In this reaction, mechanism is not important, but why I am telling you, because mostly this is the way the reaction is proceeding. Okay, most of the cases, when you have this bone shifting idea, even if you actually, even if you are confused about some mechanism or reaction, you can work it out. Okay, on your own, you can find it at least. All right. Yes, Aditya.
Ma'am, could this have been possible with the free radical methods? Ma'am? Like,
Free radical methods mostly comes in either peroxide should be there as a reagent. Their free radical mechanism, you can guess. You can go for free radical mechanism or chlorine in presence of photolysis.
oh, okay.
Okay, there, that's a must. Or in some cases, carbon to carbon, some sensitive compound, carbon to carbon bond is broken via free radical mechanism. That is something specific. You don't have to learn it here, at least not now. Okay. So that is about aldehydes. What about ketone?
Ma'am, they'll form secondary alcohols. Like,
They should form secondary
alcohols.
alcohols. Okay. So acetone will give isopropyl alcohol or propan-2-ol. That means your secondary alcohol. Any possibility for tertiary alcohol? No, isn't it?
Actually,
There is,
carbonyl compounds is not possible.
yeah. So there is no possibility for the formation of tertiary alcohol. So I'm clearing the drawings here. For acetone, it is like CH3, C double bond O, CH3. There, when hydrogen and Raney nickel is reacting, what happens? You will have CH3, CHOH, CH3. So what happens? This is isopropyl alcohol, or better say propan-2-ol. Propan-2-ol. Okay. Now, what are the reagents you can possibly use for the release of nascent hydrogen? They are powerful, but what is it?
LiLH, lithium aluminum hydride.
Lithium aluminum hydride or sodium borohydride, both are same genre. Okay, they are of the same genre. One of them will be a bit more stronger than the other. Depends on what reactant you are taking. Okay, nature of solvent, all those things. Whatever it is, you don't have to get confused here. Here you have to know only one thing. Either NaBH4 or lithium aluminum hydride, that is LiAlH4, will be involved as a reducing agent to release nascent hydrogen. They are specific reagents. Not highly specific, but still they are specific reagents. In some cases, they will react. Some cases, they don't react. But in this case, it will react. Okay. Like what cases it doesn't react is when there is this conjugation is involved, it won't react, kind of like that. But you don't have to learn that now. That is something more to this. Okay. So the reactions are when aldehyde is coming in. Okay, when aldehyde is reacting with either zinc amalgam H2O or NaBH4 or LiAlH4, you will get methanol. Okay, if it is ethanol, you will get ethanol. If it is acetone, you will get propan-2-ol. Okay, so here only thing you have to do is same reaction, reagent is a bit different. Okay, HCHO. What happens when you are using sodium amalgam and H2O? Sodium mixed in mercury plus H2O. Why sodium is not directly used in H2O?
Fire, it will cause.
Fire. Okay. First problem is fire. Second problem is whatever is formed as NaOH. not H is not formed. Hydrogen is not formed. Okay, NaOH is formed. Even if it burns, you will do it in controlled condition, whatever it is. Okay, like that doesn't spurt onto you, whatever it is. But here the problem is NaOH is formed. The reagent is different. So here when CH2 is involved with the presence of sodium amalgam H2O or NaBH4 or lithium aluminium hydride, what happens? You will get methanol, CH3OH. Same goes for ethanol to methanol. Okay, sorry, methanol is formed here. From ethanol, you will get ethanol. From propanone, you will get propanol. Okay. So this is the reaction. This is the method of reaction. CH3, C double bond O, CH3. There in the presence of LiAlH4 or NaHgH2 or what zinc amalgam is H2O, whatever is hydrogen is released. Okay, and you are getting a reduced product. Whatever there is, the reduced product is formed. Okay. So that's it. I will show you the notes so that you can take it down, and that's it for this portion. Okay, this is comparatively an easy portion, not much of a trouble. This one, have you taken down, all of you? Acetone, you are yet, anybody yet to complete? Ashwin, turn your camera on. Hari Siddharth, turn your camera on.
Ma'am,
Yes,
ma'am, I need the before slide also, ma'am.
before slide. Okay, previous slide is here. So
Even-
previous slide, from previous slide, I am showing from the reduction first slide. Please take it down from the first itself. Sneha, what is your problem? Same, I guess.
Ma'am,
Yes, ma'am. The same.
All right, okay. Yes, Ashwin.
ma'am, actually, could you give a quick recap of what this is, ma'am? I went out, ma'am.
Okay, not a problem. That is Ranne nickel is a catalyst that carries hydrogen.
Ma'am, before
redu-
topic of this reduction and
Nothing.
hydrogenation.
Nothing. Reduction means nascent hydrogen is released. That's all. Nascent hydrogen is released from Ranne nickel, hydrogen in the presence of Ranne nickel, or NaBH4 or lithium aluminum hydride. That is the common reagents we use.
Okay, ma'am.
That's all, Ashwin.
Ma'am, why we are using this in this reaction, ma'am? Just to obtain nascent hydrogen.
What is it?
We are using these type of catalyst or this Ranne
Ranne nickel is the catalyst for directly taking hydrogen. Okay, hydrogen is
Okay.
carried by Ranne nickel.
Ma'am, could you say that two hydrogenation, ma'am? One is catalytic and another one is.
See, non-catalytic hydrogenation is mostly non-existent. Okay, because hydrogen is a gas, you should have something to carry it. But
Okay.
you can see that hydrogen in presence of palladium or hydrogen in presence of platinum, they are all drastic reducing agents. It will straight away go for alkanes. Like after methanol, further reduction will occur and alkanes will be formed. So platinum kind of things you cannot use. Here you have to control it. For controlled hydrogenation, you have to use Ranne nickel. Okay, Ashwin.
Ma'am, yes, ma'am. But here we are going to learn the preparation of alcohol, ma'am.
Yes.
So why are we taking nascent hydrogen over here, ma'am?
Because in this preparation, the starting compound is carbonyl compound. Carbonyl compound is a step oxidized from alcohol.
Oh, okay, ma'am. So we are using hydrogen to get the purest form of alcohol.
Get it reduced. Okay.
Okay. Ma'am.
Yeah.
Thank you.
Chandana, are you able to follow?
Yes, ma'am.
Hari, how about you?
Yes, ma'am.
Okay, Naren?
Yes, ma'am.
Rahul?
Yes, ma'am.
Your connection trouble is over now?
Yes, ma'am. Fine.
All right. Amrita?
Ma'am,
Yeah, Ashwin.
ma'am, what's that methanol 1 degree is representing?
First degree. It is primary alcohol.
First degree
Methanol,
alcohol, ma'am.
methanol, ethanol, etc. are all primary alcohols because
Okay.
this OH is getting attached to a carbon atom, and that carbon atom is getting attached to either no other carbon atoms or only one other carbon atom.
Okay.
Okay, this is an OH. It is attached to this carbon atom. It is having only one alpha carbon atom, not another alpha carbon atom. There is only one alpha carbon atom for this carbon. The substituted carbon atom is having only one alpha carbon atom. That is the primary alcohol. Got it, Ashwin?
Yes, ma'am.
Okay. Next one, when we are seeing about ketones, again, it is changing. Like the substituted carbon atom is getting attached to two alpha carbon atoms, two other carbon atoms. So it will have two alpha carbon atoms, as you can see in the next reaction. Anybody yet to complete here? No. So here is propanone. Yeah. Giving propan 2-ol. Okay. See here, the substituted carbon atom is attached to two other carbon atoms. So two alpha carbon atoms are present. So it is secondary. Ashwin, I think your trouble is cleared, right? Your doubt is cleared.
Yes, ma'am.
Naren, turn your camera on.
Ma'am, I have one doubt, ma'am.
Yes.
Ma'am, here in this left hand side we have acetone, ma'am. It's the oxygen is double bonded with C.
Yeah.
Whereas in right side it is get cleaved and we get OH, ma'am.
Yeah. That is why the hydrogen is getting added. See
so
here, carbon atom is doubly bonded with oxygen. That means the two valencies of carbon atom is attached to oxygen. So
yes, ma'am.
carbon is more oxidized in acetone.
Okay, ma'am.
Okay, now one of the H plus is attaching to oxygen and the other hydride ion is getting attached to carbon atom. Okay,
Okay.
so alcohol is formed. Now see, one of the valency has gone for hydrogen, only one more is attached to oxygen. So oxidation state decreased. It is
Okay.
getting reduced.
Ma'am, that means in this case, what is the cleavage taking place over there, ma'am?
That is electron shift. Okay, like
Okay.
electrophilic attack is first step. Electrophile, that is H plus is attacking oxygen. So electrophilic attack at oxygen is first, and then nucleophile is getting attacked with C plus, carbocation.
Okay.
That is the mechanism. Yes, Asmita.
What about the reduction of propane 1 on?
There is no such compound existing, dear, because propan 1 own cannot exist. Then it will be propanol, first degree. All right.
Yes.
Okay. Butanol means you will have isobutyl alcohol, or you can say that butan 2-ol. Anyway, it will be any ketone will give only secondary alcohol. Okay, secondary alcohol will be given. Shall we move to the next? Yeah. So here it is. So sodium amalgam H2O or zinc amalgam H2O, when you are saying, don't get any doubts, because It is all the same. All right. What happens, Neha?
Ma'am, is it the nascent hydrogen getting combined with the element or?
It is two nascent hydrogens are released simultaneously. It is attacking carbon as well as oxygen. That is the concept. But actual mechanism will still proceed in the earlier method.
Okay, ma'am.
Okay. Because nascent oxygen, the life is pretty much less. All right. But in split seconds, these reactions take place. That is what they say. Like this is faster reactions. Okay. This is very fast reaction. So pinning down the mechanism is still not possible. They are expecting both the mechanism to be followed. I don't like they are not getting a precise idea about it, but both mechanisms are seen in the textbooks. Like reference textbooks, you can see both mechanisms. Yeah. But mostly people explain the mechanism I just explained. Like H plus is attacking oxygen and then bone shifting is happening. So carbocation is formed because that is the best, what you call, best thing that can be understandable, isn't it? The understandable, most understandable mechanism is that one. So that is the way we mostly explain it.
Okay.
Yeah. So once completed, all of you give me a thumbs up. Those who have raised hands, please put it on. Okay, Neha, I can see your thumbs up. Okay, Hari, I can see your thumbs up. Okay, Naren, okay. Chandana, okay. Arpita. Rahul, okay. Hari, Siddharth, okay. Samyukta, good. Varuna, how about you? Asmita, okay. All right, Amrita, okay, Varuna. Ashwin, Aditya. Okay. So shall we move?
Yes, ma'am.
All right. Next. By reduction, you cannot prepare tertiary alcohol. Note it down. Just as a side note. Aldehyde gives you primary, ketone gives you secondary, tertiary alcohol is not prepared at all. Okay, no go. All right. Okay, so what is next?
Can you show that slide again, ma'am? The last one.
Slide is gone.
It's gone, ma'am.
Now,
Yes, ma'am.
Yes, ma'am.
now there is one information, that is lithium aluminum hydride is an expensive reagent for only for the specific reactions they are used. Okay, so from acids, when you are preparing alcohol, esters are prepared first and then they are subjected to catalytic reduction. Okay. See, when you are using lithium aluminum hydride, it is simply a straight method. Okay. But instead, you go a step ahead and then backward. You are preparing ester first and then you are getting it reduced to alcohol via catalytic reduction methods. Okay. Because sodium borohydride and lithium aluminum hydride, both are specific reagents and they are expensive. So this is the way we use it. So from acid, from lithium aluminum hydride, it is simple. Straight reduction will result in this double bond O. C double bond O is replaced by hydrogen itself. That's all. But actually, that is not what happens via mechanism. Mechanism, first water is eliminated, then what hydrogen is added on carbon as well as oxygen. Okay, that's how it is done. But generally, the way we do it is the first place you are converting acid into ester. Okay, esterification is first done. After esterification, you are using some catalytic reducing agent, not lithium aluminum hydride always. Okay, mostly what we'll use is hydrogen in presence of iron and nickel or some other cheap reducing agents that will give you alcohol. Both alcohols are given, but it will be a mixture of alcohol. It would be a mixture of alcohol. So to make same kind of alcohol, what you are going to do, okay.
Ma'am, the carboxylic acid and this alcohol that we're using should be the same.
Number
Like
of,
symmetrical.
same number of carbon atoms should be there. That's it. Okay. So the point is what? If you are having CH3, C double bond O, OH, and you are having R dash OH, what should be this R dash OH? CH3, CH2, OH should be taken. Now what happens? You will have CH3, C double bond O, CH2, CH3. Now after this cleavage and hydrogen addition here and here and hydrogen is added here, all those reactions, after all those reactions, what will happen? You will get, after this hydrogen and iron nickel, that experiment, you will, after that reaction, you will get CH3, CH2OH on both sides. Here also CH3, CH2OH, here also it would be CH3, CH2OH. So 2 CH3, CH2OH will be produced as a result. Now listen, for seeding, you need the same thing in the first place. What should be your product? That should be there in small amounts in the reactant side also. Small amount. The rest it will be self-catalyzing. Clear? It will proceed itself, isn't it? So that's how it is proceeding. So just remember this point. Sometimes for logical type of organic question or twisted question, if you are expecting, this can be one of them. Okay. Clear? Any doubts, anybody?
Ma'am.
Okay. I can repeat it, not a trouble. Listen, when you are intended, like you have the intention to make, Asmita, are you there? I think you logged off.
I'm here, ma'am.
Yeah, okay. So CH3, C double bond O, OH. So from this, what will be the straight product? Straight product, one carbon atom is here, one more carbon atom is here. So from this, you are going to expect only CH3, CH2, OH. Am I correct? Ethanol.
Yes, ma'am.
But when this esterification is the first step, instead of this hydrogen, some R dash group should be incoming. This R dash group should also be CH3, CH2, including one. Otherwise, you will have a mixture of some other chemicals, isn't it? If you are taking only methanol, what will happen? One of the product itself will be methanol. Okay. And what you are getting is a mixture kind of one, isn't it? Total reaction will result in a mixture of product. Mixture, when you are purifying it, it is not an easy job. Okay. So CH3, CH2OH itself you are using as the esterification agent means what you are going to get is what? Ethyl acetate. Okay, so CH3, C double bond O. I will get back to you, Aditya. O, CH2, CH3. So now in this cleavage here, one hydrogen is added, one hydrogen should get added here, two hydrogen should get added here. So what happens in a total? 4 hydrogen via hydrogen in presence of iron and nickel or NaBH4 or LiAlH4 etc. should be formed, and finally you will be getting 2 molecules of CH3, CH2, OH. No purification required. Clear? Yeah.
Yes, ma'am.
If you are taking propanoic acid, the esterification agent should be propanol. Okay, that should be the way it proceeds. Okay. Aditya, what's your doubt?
Ma'am, so the doubt is basically like, are we getting the like, does this follow from the carbonyl compound, or is it like the preparation from acids itself, like a separate one now?
From acids. When you are taking acids and you are like having the intention to produce
Yeah, okay.
or prepare alcohol.
Because the
That's
last point that you showed, ma'am, I thought like maybe the carbonyl compound is oxidized into acid, and then from again
no,
from there we are
no,
doing
not
some
that.
juggling. And
From acid, when you are preparing, you are converting acid into ester first,
yeah.
and then from there you are
Okay.
getting. See, for aldehyde, you don't have to go as far as lithium aluminum hydride. You have ranitol nickel. That is enough.
Ma'am,
Okay.
so just one moment.
Yeah, not a problem.
Over here, if we use a symmetrical alcohol, it will become the preparation of that thing itself, right, ma'am?
Okay, it
But
would be
if we have like a methanol with ethanoic acid, so would it, since we are getting methanol back, would it be called a catalytic reagent now?
not necessarily, because again, the produced ethanol can also be acting as a catalyst.
Oh, okay, ma'am, I get it.
Anything, yeah, anything can do that. So
Thank
to
you.
stay in a better shape, this is the best way to proceed it. Like when you are asked this question in that way, mostly this general equation will be what you will be asked in the question paper. But if at all they are twisting it, this is the answer you should go for.
Okay, ma'am.
Okay, so shall we go? Shall we move further? Rahul, I can't see you. Hari, I can't see you.
Ma'am, just a minute, ma'am.
Okay. Rahul, your video is off. Still off. So next reaction is when you are having cyclohexanone, what you are going to get is EC cyclohexanol. Okay, cyclohexanol. But oxidation reduction reaction is here. Equilibrium reaction will be what it is proceeding. Okay. It's not a sure shot reaction. Always there is a chance for backward reaction. Okay, according to the stability factor. Okay. So just note it down. This is a forward backward double-sided reaction. That's all you have to remember. Completed here, all of you?
Ma'am,
Yes.
ma'am, does it all comes under preparation of alcohols, ma'am?
Yes, preparation of alcohol. The main heading is preparation of alcohols.
Okay.
Now, what is the major method of preparation? Grignard's reagent yet to come. All right, so completed here, all of you. Okay, Naren. Okay, Sneha. All of you. Any reasons? Any reasons? That's all I need to know. Any reasons? Okay, okay. Continue. Yeah, thumbs ups also I can see. Good.
In the previous reaction, we have 2H2, is it?
2H2O. 2H2O. What is that?
For 4 hydrogen to be added. ma'am,
Yes, for
we have
4 hydrogen to be added, 2H2 in presence of nickel. Yes. But in the reagent column, you don't have to specify the balanced chemical equation or so, not required. Okay. Only nascent hydrogen number you have to specify. Still, it is for only for your knowledge. Okay. Mostly this balanced chemical equation headaches comes in your description type examination, of course. Not just that, the headache comes in only in inorganic chemistry. Organic chemistry, there is no this balancing of chemical equation is not a trouble. In few reactions, you have to check for it. Other than that, there is no trouble. There, recognizing what reaction is happening itself is important. Okay. So, balancing is not a question at all. Recognizing what is forming. Okay, there you will be nailed. Okay, Aditya, completed. Anybody yet to complete? No. So, from Grignard's reagent. What is a Grignard reagent? First of all, for this Grignard reagent reaction, you have to prepare Grignard reagent. First step. What is that?
Ma'am, alkyl halide in the presence of magnesium, with magnesium in the presence of dry ether. Ma'am. Yes.
Okay, good. It will give you what? RMGX. This X can be either chlorine or bromine. Better take bromine. Okay. Mostly what we are saying is RMGBr. But general reactions, you can write RNGX. Just keep it in mind. Mostly it is chlorine and bromine. Never fluorine. Okay. Remember, never fluorine. All right. Chlorine, bromine, some cases iodine also okay. Not fluorine. All right. Ashwin, what is your doubt?
What is the topic of this one? Now, this student listen.
They didn't understand your question.
What's the topic teaching
Yeah,
moment?
from Grignard reagent. Preparation of alcohol from Grignard reagent. Grignard. Grignard's reagent is one of the very important reagent. Even in the middle of sleep, you have to recognize this reagent. Okay, if you recognize this, half done. With your entrance question paper, you are half done. Entrance question, you are half done already. Okay, so recognizing this is, it is easy to recognize, but protect, that is what I mean. Okay, what product you are going to get, you have to immediately recognize. Then you are half done with your question. Like within 30 seconds or so, you can answer the rest and get to the option. Okay. So now you got RMGX. Now what to do? R is here, MGX is here. What
It's
is this?
very reactive, ma'am. It will react with water.
It will react with water.
And wherever that MGX was there, H will come, ma'am. In place of MGX, H will come, ma'am.
Okay.
And it will form MgOH. This one. MgOH will be formed.
Okay. So that is the first thing that happens. RMGX is formed first. Okay. Alkyl magnesium halide is first formed. And to this, what is added? What is added? What is added then?
Carbonyl compound.
Not carbonyl compound. Carbonyl compound you can add. That is one of the reaction to make tertiary alcohol. Yes. Okay, so let us see the reaction in detail because not much to learn, but a fixed thing to learn. All right. So fixed reaction, methods of preparation of alcohol from Grignard's reagent. The reagent used for converting ethanoic acid to ethanol is from here, from the options. What is the answer?
Ma'am, can't see the question.
Great. Now,
Yes, ma'am.
yeah, what is the answer?
Option A, ma'am.
Aluminum
Option
hydride.
A, lithium aluminum hydride. Very good. Now I want you to read this question and come up with an answer within 30 seconds. Time starts now.
Alcohol.
Esterification of carboxylic acid followed by reduction with lithium aluminum hydride yield
Alcohols.
alcohols. Okay. So from Grignard's reagent, what happens? Alkyl magnesium halide. The first step is nucleophilic addition of Grignard reagent. Again, okay, what happens? You are having either aldehyde or ketone. You are taking either aldehyde or ketone. That means carbonyl compound is the first step. And that with the Grignard's reagent will result in the formation of, okay, result in the formation of what? R double dash. That is, whatever alkyl group was there in the Grignard reagent will attack carbonyl carbon atom. Bond will get shifted. There, MgX will get attached. What is the speciality of Grignard reagent? Grignard reagent. Yes, what is it, Aditya?
As soon as you add water, it will the MgX will just go away, ma'am, and it will
Yeah.
replace with hydrogen.
That is the
Yes.
mechanism, or that is the procedure, or the way it is proceeding. Okay. My question is, what is the speciality? Most of the reactions so far, have you ever noticed? You haven't ever seen any reaction with carbanion. Have you ever seen carbanion? Carbon minus? Never, right? But here, Grignard reagent is actually producing carbanion. Carbanion formation is one of the primary steps. Why? Because I will say R double dash MgBr is there. When it is reacting with R dash C double bond O R in this pattern, what happens is, first of all, this R dash is attacking carbon, then the bond is shifting towards here. So if the bond should shift towards oxygen, the oxygen is now O minus, means what? Already attacked thing was a negative one, isn't it? See, that means R double dash was becoming a negatively charged one. That means carbanion is formed here. Carbanion nucleophilic attack is initiated by RMgBr. MgX portion is becoming positive. This positive entity will then become attached to oxygen. So what happened? R double dash is here, R dash is here, R is here, and O minus, then it is actually attached to oxygen. Here with what? Simply in the presence of water, okay? Simply in the presence of water, you can get tertiary alcohol. Tertiary alcohol can be prepared in this method. Now, what is the specialty of carbanion? Stability of carbanion is actually somewhat a question mark, but with this conjugation with what you call carbonyl carbon, It is pretty much stable. See, carbocation, the stability order and these things we always check. Tertiary greater than primary, secondary greater than primary, all those things. But carbanion formation itself is a bit difficult. For carbon to hold its own electron alone is a bit difficult. Okay, so this is the way this reaction is proceeding. I will show you the slide and there you can take it down. That is the best way because there is no detail which is okay. Here also acid hydrolysis is what checking in. Okay, you have to understand that this is also acid hydrolysis. Okay, now take it down and then we will move to the next. One of them.
Ma'am,
Yeah.
ma'am, in acid hydrolysis, what will be the byproduct, ma'am? Means which will get liberated.
H plus is released from acid. Okay, so automatically the water will become H3O plus. Okay,
Okay.
so oxygen is already in plus charge, so release of this OH is easier. Okay, it will easily get deprotonated.
Okay.
Okay, that's all.
Does this result in hydrosonium?
No, hydronium ion.
Okay.
Yeah. Okay.
The
Yes,
compound
Samyukta.
mentioned in square bracket is intermediate, right?
Intermediate. Yes. Yes. R-Mg complex or magnesium complex or Grignard reagent complex. It is called. Okay. Grignard reagent. What is it, Aditya? Didn't hear you. Nothing. Okay. So this is an intermediate that is mentioned in square bracket. Yes. Which means what? It is a bit unstable. Okay, that is another thing. It is a bit unstable. So it will easily undergo acid hydrolysis. That is another meaning. Okay. The last step is one of the fastest step. Yes, Aditya, what is your doubt?
Ma'am, you said only tertiary alcohols can be prepared this way, is it, ma'am?
Yes.
Ma'am, so if we have methanol as the starting agent, ma'am,
Yeah.
can't we prepare primary alcohol that way also, ma'am? Or maybe if we have like ethanol,
Still
we can
not
prepare secondary
primary.
alcohol.
Okay, still not primary. It will still give you only secondary, right?
Methanol.
Methanol will
Okay, methanol. All right. Okay, yes. Methanol means like formaldehyde means it is primary alcohol then.
Oh, okay, ma'am.
Okay. Not like.
It's not strictly tertiary.
Ah, yes. Not strictly tertiary. See, tertiary methods of preparation for tertiary. Have you ever seen now this day today?
No, ma'am, I got it.
Yeah. So this is one of the method that you can prepare tertiary. Okay, HCHO and RMGBR means this R will get attached here. Okay, and OH is here. This mechanism is only for your understanding. When you are getting this reaction in your entrance examination, you know, how would it look like? It would look like only this. CH3, C double bond O, CH3 in the presence of, you know, they will give it like this. RMgX and H3O plus. Okay, or they will give it in detail as this way. That's all. Sometimes it is reacting, it will be a story. Story in the sense, what you call? Your
statements.
Yeah, statement type. I will tell you. A reactant A reacts with magnesium, like a haloalkene reacts with magnesium, and the product reacts with a carbonyl compound on hydrolysis gives tertiary alcohol. Okay, kind of like that. You have to work out from first to last what has happened. Okay, so that's only there, only then you need some bit of this mechanism. The actual mechanism doesn't matter. Where it is attacking, where that is attacking is just for you to learn, that's it. You should know it, that's all. But mainly what we need is the product. This question mark should be answered. Okay, then your answer is what? CH3 is here. Okay, CH3, not CH3. Okay, CR is here, CH3 is here, and OH is here. That's all. You should know that. That's all. Only thing is that this R will come here. Of course, MgX will come here. MgX is removed, H is coming in. That's all you need to know. All right. So keeping it simple and with the mechanism, keeping it explained. Both should be there in your brains.
Ma'am,
Yes, Asmita.
so if we take n number of carbon atoms, the product will have n plus 1 number of carbon atoms.
Where does that come from now? Actually, if there is 2 carbon atom, okay, towards the carbonyl carbon, 1 more carbon atom will come and attack. Yes, that's the best way to explain it. Not like n plus 1. Whatever is incoming alkyl group, it attacks as such.
So if we are given a product and they're asked to find the reactant, we
Easy
have to
to find.
subtract the number of carbon
Not
atoms.
subtracting, not subtraction. Okay. What was the one of the reagent, one of the reactant will be given, one of the substrate will be given, the other one you will have to find. The odd one out you have to pick out. We will work out one problem. I guess one problem is there in my whatever I have prepared. Okay, we will check. Okay, now, so this preparation is done. Now, after Grignard reagent, what we have is properties of alcohol. So before that, I'll give you a few questions. Can you all see the screen? No. Now, Lucas reagent, let it be there because it is coming in the properties side. Okay, given not reactive, then again preparation, not properties. Okay. Again properties. Where comes preparation? Yeah, this is one of the question. Okay. Take it down. It's a bit complicated. Do you remember earlier in the last class, I have already told you questions from this topic doesn't come from this topic alone. It will come from different chapters and it will be a mix, a sequence. One such sequence is this. Please take down the question. I will explain.
Ma'am, what is the second reagent?
First reagent is PCC, that is pyridinium chlorochromate.
Yes, ma'am.
Second reagent is diol, glycol. Okay. It is a protecting agent. What is pyridinium chlorochromate? What is it? A reducing agent or an oxidizing agent? What is it?
Oxidizing.
Oxidizing agent, isn't it? It is a specific oxidizing agent. Now, glycol is a protecting agent. Okay, it is a protecting agent. Third one is the actual reagent. From B to C, the actual reaction takes place. Okay. C to D is simply retaining the reactant. Okay. Done with the question, all of you?
Yes, sir.
They simply ask what is D. Okay. They simply ask what is D, and you will be surprised why we were working out so much and finding the answer. At the examination hall, you cannot find a straight answer because you have to do it systematically. Otherwise, there's chances that you might go wrong at one of the step. It will give you negative mark. Okay. So while dealing with this type of questions, please be extra careful. That is one thing. Second thing is, maximum do this question in the second round. Don't waste time in the first round itself. Okay. Just mark the question number. Okay. If this is computer based exams, if it is in computer based exam, just note down the question number. For NEET and all, it is still in the paper mode. Circle it, come back and do it. Okay, not in the first round. Don't waste time in the first round. First round is for rapid round. Second round, you can elaborate. Okay, first round should be your rapid round. You are fresh and you can immediately think and answer. Enough. It is rapid round. Second round, come back to the marked questions workout. Okay, bubbling should be done in each round. First round, rapid round is complete, means bubbling should be done parallelly. Then come back for a second round, bubbling should be done parallelly then. And then to the third round, if there is time, work out the difficult ones. If you are 100% sure about the answer, go for it. Okay, don't buy negative marks. All right, now, first thing, you have pyridinium chlorochromate. What is the speciality of this compound? One of the alcohol is secondary, the other one is primary. Okay, one of the hydroxyl group is primary, the other one is secondary. That is the specialty. Otherwise, why should they give you 2 OH in the same compound and ask you what is the product? Okay, why? You should know what they are thinking. What the question paper people are thinking. That you have to think first. Okay. So, there you are adding PCC. Pyridinium chlorochromate is a drastic oxidizing agent. Oxidizes anything that comes in its way. Okay. So, immediately you will get double bond O here and double bond O here, of course, NH. Here, secondary alcohol will be converted into ketone. Primary alcohol converts into aldehyde. Now, ethylene glycol. Specific protecting agent. Whether it protects ketone or aldehyde is our question. Which will it protect?
Ketone, I think.
It will protect ketone or aldehyde. Whoever has the answer. Okay, one option for ketone. Any other options for anybody else?
I'm going to say aldehyde.
It is aldehyde. Okay. It protects specifically, aldehyde is getting protected. Aldehyde is specifically protected by ethylene glycol. So, oxygen, oxygen, and the bridge. Okay, methylene bridge.
Ma'am, with
Yeah.
ketone, it forms a ketal kind of structure. Is it something that
Hemiacetal.
Yeah.
Hemiacetal structure is highly unstable. In a secondary way, it won't come near it. Preference will be here. There will be this preference. Okay. Okay, so that instability, it won't go for that. Okay.
Ma'am, it just reacted with aldehyde, ma'am. So how is it protected, ma'am? Yeah.
It reacted with aldehyde such that the double bond O is removed. Now there is no carbonyl carbonatom here. The carbonyl carbonatom is existing only here. Now to this, the RMGBr is coming in. here we have in our question CH3 and GBr, I guess, right?
Yes, ma'am.
So what is our product? Here will be there our CH3. Here will be our OH. Am I correct?
Yes, ma'am.
Okay. And our protected thing is here. Okay. So RMGBr and hydrolysis is also given alongside. That is why I straight away wrote the answer. Okay. Now to the D protection. What is it? Ethanol and sodium hydroxide is given, or what? Sodium hydroxide, definitely. What is it? What is the other one?
Sodium borohydride and ethanol, ma'am.
Okay, sodium borohydride and ethanol. So reduction and ethanol. Okay, so what happens? This is removed. This is an oxidizing. Ethylene glycol is an oxidizing agent. Instead of a double bond towards oxygen, it provided with 2 oxygen atoms separately. Okay, bonus. So it is another oxidation that happened. Now reduction. Okay, to get back. So now what happened? CHO is still there and drastic reduction is happening. So CH2 OH is getting back, and here Me is there, here OH is there. Simply what happened? Here the secondary alcohol is made a tertiary alcohol. That's all. See, for this you have come 4 steps this long. That's why I told you come back for a second round to work out this kind of a problem. Don't waste time in the first round. Got it? Because there you can already, you have seen all the question. Now you have this preference order. Instead of going for organic tough question, you can go for an inorganic easier tough question. Okay, like you will have that priorities. Okay, so you can prioritize your second round questions. Okay, this kind of questions, I think some of you will be preferring for the third round. All right, so it is according to the easiness with which you are handling organic chemistry. You have to take the choice. I will show you the slide for the answer. Here it is. Okay, so take it down. Anybody having any doubts? No doubts. Okay.
Ma'am, I have a question, ma'am, but it's unrelated to alcohols, ma'am, but it's related to this.
What is it?
Ma'am, it's like my question is like you said we can have first round and second round, and then we have to come back to questions in the second round, ma'am. So is it more like we'll have physics, chemistry, maths all 3 together in the exam, right, ma'am?
Yeah.
So is it more like we start with whichever is easy, maybe chemistry, ma'am?
Yeah.
We start with chemistry and the first round we do, and then we continue with physics the first round, and then we continue with maths the first round. Then we come back to chemistry and see the tough question on the second round, or is it like we are advised to complete chemistry fully?
No. Not that. The very first one you said. First 1.5 hour PCM completed. Second,
Majority, ma'am.
yeah. Second, whichever is easier, that priority basis. You have to come back.
Oh, okay, ma'am. So if we do that also, wouldn't it be like our attention is like divided between these 3?
I would say one more thing.
Yes,
Like when you are sticking to one subject alone, finally you will only get confused. A distraction is sometimes good for you. Okay, this first round, second round, third round basis, when you're going for this, sometimes when you are attending chemistry thermodynamics, okay, this has happened to me. That's why I'm sharing this experience. When I was attempting chemistry thermodynamics, I didn't have an answer for one question. Physics, there was an adiabatic or something like that, a question. I could easily answer that. I got the idea about how to answer the chemistry one. That will actually ring a bell, or what you call, strike a bulb or whatever. Okay, so some distraction from subject to subject, that will help in some places. Yes.
So in general, you're saying out of the 75 questions as a whole in all subjects, just we'll go through first round and answer.
Yeah.
And then we can
So you
later
are
come back.
familiar with all the question all at once.
And then whichever we know, we
Okay.
can answer in the first
Whatever
time.
is rapidly answered, okay, you are done. So you don't have to get tensed. Okay, 1 hour is over and I have done only chemistry, or I have done only physics. Now 2 more hours, how to manage it? Not that trouble at all. Okay. 30 minutes chemistry, 30 minutes physics, and 30 minutes mathematics. You are done with the first round. Now at least you know that within the first what you call 60 plus minutes, that is enough. Okay, first 50 plus minutes or 60 plus minutes itself, you are familiar with every questions. Now you know what you have missed, what you have to think, where you have to work out, where you don't have to waste any time. Okay, go back and do it. Okay, so that way time management will be a bit more easier. That's it.
Okay.
Okay, and please do remember one more thing: not correct, incorrect, true, false, etc. Please note mentally. Please make a mental note when you are looking at the option. Okay, this is false. Okay, this is also false. Whether it is true or not, I don't know. Okay, whether that is true or not, I don't know. What is the question now?
So the following is not correct.
Okay, then that will be a trouble again. You will be reading all over again, and still you are not finding the answer. You are going for an option which is wrong, means gone, negative mark. Okay, take care when you are attempting that type of statement questions. Okay, this type of question, at least you can work out and find a right answer. That type of question is simply carelessness mistake. Okay, you would be blaming yourselves for that one mistake alone. So now completed here. Yeah, I can see reasons. Okay, so this, yes,
You have
Amita.
written that ethylene glycol is a protecting. Yeah, you have written
Ethylene
something.
glycol is a protecting group.
Okay.
So the thing
Ma'am, is
is
ethylene glycol protecting aldehyde or ketone? Ma'am?
aldehyde.
Ma'am,
Specific.
then why is it reacting with aldehyde?
What should I say for this? I don't know. Actually, for a protecting group, it is not like bubbling it, okay, or covering it. It is like it is reacting so that other reagent won't come and attack. But to retain it, you have an antidote. I don't know how to place an example. The problem is this protecting group, you are only learning at the specific reactions. That's all. Protecting group is actually a full-length chapter for PG. PG chemistry, it's a full-length chapter. Okay, there we are going to see the mechanism with which it is working, etc. So it is a different story. Thing is what? It will react with aldehyde and carbonyl compound is converted into carbon having bond with two different oxygen atoms, and it is in a cyclic form. There another electrophilic attack or nucleophilic attack. Nucleophilic attack is not happening. A nucleophilic attack is not entertained. Okay, but in the secondary, sorry, ketone, the secondary carbonyl carbon, there nucleophile is coming and attacking it. Okay, because Me is in Me minus, carbocation is coming in. Carbocation is negatively charged, so it is a nucleophile. It loves nucleus. Okay, doubt cleared, Aditya? Okay. Yes, Sneha?
Ma'am, are those hydrogen and hydronium ions released out, or what is this?
Hydrogen and hydronium ion. Hydronium, okay, that is simply acid hydrolysis. Okay, simple acid hydrolysis mechanism is followed.
Okay, ma'am.
Okay, don't have to think about all those mechanisms and all. Here, when these in these kinds of questions, to like one product is formed from as two reagent means it will be given in a single arrow mark itself. One particular reaction. Okay. So that is
Okay.
not a trouble. Okay.
Okay.
Next question. THF. Yes. Again. RMGBR. See, they have simply given a story in a.
Ma'am, if it's a slideshow, ma'am, it's actually not visible now.
Okay.
But the same slide was visible earlier, just as a normal slide. Ma'am. Yes, ma'am.
Okay. 5-bromo 2-pentanone in the presence of Mg and THF. X is given. Hydrolysis gives Y. What is X and Y? Okay. So what is THF? Tetrahydrofuran. Tetrahydrofuran. What is furan? All the
Furan is
double
like 4 carbons and then 1 oxygen as a fifth,
oxygen.
ma'am.
Yeah.
It's a 5-member ring.
It's a
It's
5-member ring.
conjugated.
It is conjugated. It was conjugated. Tetrahydrofuran is the unconjugated thing.
Okay.
All right.
Could you get the
So-
structure, ma'am?
So here you have 5-bromo 2-pentanone. So CH3, C double bond O, CH2, CH2, 5-bromo they have written, isn't it? CH2, CH2Br. So 2-pentanone, 5-bromo. Clear? Now what they have given? Mg is there and THF, tetrahydrofuran is there. Tetrahydrofuran is simply a medium. Okay, this is the compound. Earlier it was furan. These double bonds are broken and hydrogen is replacing it. THF. This is THF. Okay. Now, what about THF? What is the specialty of THF? THF is simply a medium, a solvent for Mg. Why? Mg will react with hot water. To avoid it, you are using some other medium. That's all. It is an organic reaction. So THF, you don't have to pay any attention. But remember, don't think what is that reagent? What is that reagent? Will it react? No, it is simply a solvent. All right. Now Mg is there. What happened? Samyukta, is that you having a raised hand?
Yes, ma'am.
What is the doubt?
In DHF, like oxygen will be having another lone pair, no, ma'am. Why we are not representing it?
It is there. It is there. Okay. Why we are not representing means only one pair gets into this resonance. The other pair will remain outside. That's it.
Yes, ma'am.
So this Mg will get in between this one. So what is it? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Double bond O and Br. Okay. Now not Br, MgBr. Now what happens?
And they're again acid hydrolysis.
That's all. That's all. Where is this one and where is this one? What should happen? RMGBr should react. Where?
Does it form a closed cycle?
It will form a cyclic compound. Okay. So first carbon atom is left out. Second carbon atom is here. Third carbon atom is here. Fourth one is here. Fifth one is here. Fifth one is again getting attached to the second one, isn't it? 1, 2, 3, 4, 5. Okay. So 1, 2, 3, 4, 5. Okay. Okay. Now what happens after hydrolysis? You will be getting, here will be your OH, isn't it? Carbon addition has already happened in this carbon, second carbon atom, and OH is here. So this is the way this reaction will proceed. Okay, this is the way this reaction is proceeding. And here is the answer. Yes, Samyukta.
Once again, can you explain how that cyclic structure we got?
Okay. First of all, this kind of a reaction to save time. Okay. Use the dash method. In the answer slide, I have written in the full format, that is to avoid confusion. But actually, when you're doing it in the examination hall, have the practice of dash method. Okay. So 1, 2, 3, 4, 5, fifth carbon atom having bromine. Okay. In the step 1, Mg is getting added. So you will have MgBr. Okay. Now 1, 2, 3, 4, and 5. Okay. So 2, 3, 4, 5. Fifth carbon atom will attack carbonyl carbon, and this bond will be cyclized. So 1 is here itself. 2, 3, 4, 5. Okay, 5 is attacking 2. So 2 is here, again here. So OMgBr. Now what? This will get hydrolyzed, acid hydrolysis, H3O plus. Okay, so again this 4-membered ring and OH. That's all. Okay, cyclization. Don't get confused. Follow the numbers. In what all number, what all substituents are there, don't forget to write it down. Okay, that's all. All right, I will show you the answering slide so that you can take it down. What is your doubt, Aditya?
My doubt is like wherever there is an MgBr attached to some alkyl C,
Yeah.
whether it's in the same compound or it's in the different compound, if there is a carbonyl compound, it will immediately attack it, and whether it forms a cyclic or not, it will just attack and form a compound. Is it
Form a compound, yes.
Is it a general reaction? Like
yes,
we can
it is. It is. It is.
trust it anywhere.
Yeah.
Okay, sure.
It is because our MgBr is capable to form carbanion. Carbanion is one of the best thing that can attack carbonyl carbon.
Okay, ma'am.
Carbanion formation is important for attacking carbonyl carbon. Okay, carbocation cannot do that.
Okay. Instead of an oxygen, like an oxy bond over there, instead of that, if we had a halide, like a CCl, like we learned in the regular alkanes chapter.
Alkanes chapter, yes. There also the story is different, isn't it? Carbanion is formed, okay, but there is no carbonyl carbon. You don't have to bother about the there the chlorine will be a leaving group. Here leaving is not there. Oxygen is still staying here.
Okay, ma'am. So that won't form like a cycloalkane, ma'am.
No, because chlorine will immediately leave.
So there's no formation. So only with carbonyl compound.
There is intramolecular reactions happening, yes.
Okay. But with carbonyl compound, we have to be careful.
See, this is a 4-membered ring that is forming. That is why it is happening. If it was a 3-membered ring to be formed, ring will not form. Instead, 2 different compounds will attach. 2 different compounds of the same thing will attach, will get attacked each other. Okay, that is the way. All right. Because 3-membered rings are ring strain is more. Here ring strain is less compared to that. Okay, so once completed, those who have completed, you can leave, and we will see preparation properties in the next class. Okay, properties plus phenols we will start in the next class. Okay, we have to discuss some 35 questions in this sequence. Okay, like this pattern questions. These are all JEE pattern questions. Okay, few of them are JEE advanced 11 questions.
Okay.
Few of what we are discussing. Yeah.
What is THF?
Tetrahydrofuran. tetrahydrofuran. Okay, Sneha, what is it?
Ma'am, is it only Grig? I don't know how to pronounce that.
Grignard.
Grignard's reaction. Is that the only method to produce a tertiary alcohol? Or
So far,
are
we
there
have only seen this one as tertiary alcohol. Yeah,
only one, ma'am? Okay, ma'am.
only one. But alkene, there is one, isn't it?
Yes, ma'am.
Yeah. Other than that, this is one of the method. Yes.
Okay, ma'am.
And those who have completed, you can leave. Not a problem.
Thank you, ma'am.
Thank you.
Good night, ma'am.
Thank you,
Good
ma'am.
night. Thank you. Good night.
Good night, ma'am.
Thank you. Good night.
Thank you, ma'am.
Thank you, Ashwin.
Thank you, ma'am.
All right, Hari. Siddharth, I was calling you. Like I was going to call you Siddharth. All right. Okay, Hari. Samikta, Aditya.
Done, ma'am. Thank you, ma'am.
Okay, done. Thank you. All right. Aditya.
I'm just 2 minutes.
Yeah. Now you understand the importance of carbanion formation, right?
Yes, ma'am. That it can attack this carbon and get
Carbonyl
it
carbon,
to
yeah.
get reduced down.
Attack on carbonyl carbon
Yes, ma'am.
is a point. Okay.
It won't
Because-
attack oxygen, ma'am. That's
No,
obvious.
not attacking oxygen.
That's
Yes.
obvious. Ma'am, you said 3 carbon ring is a bit unstable, ma'am.
Unstable.
4
Three
carbon
is
ring is
bit more stable, better. That's all.
like as far as I've heard, ma'am, 5 and 6 carbon rings are considered to be more stable, ma'am. So
Of course.
wherever there is a possibility of formation in some reaction, we better take that.
That one.
I mean,
More.
yes.
Yeah, more the number of carbon atom in the ring, that is preferred.
Ma'am, so but I have never yet seen any 7 or 8 membered ring anywhere,
7
like
or 8
reaction anywhere.
membered ring, there the bulkiness matters.
Bulkiness.
Okay, bulkiness will come into the question then.
Okay, ma'am.
Okay.
So that's why mostly we see only 5 and
We
6.
see only
membered
4,
rings.
5, 6, maximum 5, 6.
Even aromatics are like only 5 and 6 carbon, right?
Mostly
ma'am?
5 and 6, yes.
Okay. Okay, sure, ma'am.
Okay.
Ma'am, could you give me just 1 minute, ma'am? I'll just check through the remaining of the PDF to see.
Yeah,
if I
yeah,
have it.
Yeah, come on. It's not opening up for me. Yeah, here it is. Great.
Ma'am, so the 6th question that you want.
Ah, yes.
Ma'am,
6.
can I send-
Don't tell me question numbers because I won't remember the number. Okay. Unless it is an entrance examination, I won't remember the question numbers. Okay.
No, ma'am, you have the PDF, is it, ma'am?
Yeah, I have a PDF. Let me open it.
The one that you want sent, ma'am.
Yeah, same I have. Just a moment.
Yes.
Yeah.
Ma'am, my 6th question was that the preparation of FeCl3, one of the method was like Fe and Cl2 gas was passed over Fe, that is
Yeah.
ion.
That is
And
for
it
the
was
preparation
heated.
of anhydrous
Yes.
perchloride. Okay.
And the second point was given like the hydrated FeCl3 can be prepared by simply dissolving iron in dilute HCl, ma'am.
You keep
Since
iron and dilute HCl.
it will
The
only give
solution will
FeCl.
turn FeCl3. Okay. Iron, there also you are getting this freshly prepared ferrichloride solution you are using for this ground ring test, the green one.
Ferric sulfate. ma'am.
Sulfate only you are using. Okay, ferrichloride can also be used instead. Okay, that is in some cases. Most of the case we use sulfate only because sulfate has more density.
Ma'am, so as my question was, ma'am, like it can just pure iron be dissolved in dilute HCl to give FeCl3, or can it not, ma'am? And since you the way you answered it, I got that
FeCl3 only.
FeO is reacting with
Yes,
HCl to
FeO
give
or
FeCl3.
metallic ion directly can react.
Is it?
Is it? Yes. Is it?
Okay.
Yes.
The question actually arose because I searched everywhere, ma'am. Metallic
But
ion
even
could
I
only
don't
give
have the proof
FeCl2.
for it. That is the trouble. Otherwise, I would have given you the reaction straight away.
Okay, ma'am. So I think I'll just note that.
Even
down.
yes, even I was not getting it. I didn't see anything in JEE. These are quotes from Hughey's Inorganic Chemistry.
How many lists do you have?
We have a lot of books. Okay, Puri Sharma and Patania. Okay, it is a undergraduate mere reference. That's all. JD Lee is some of which is very strongly recommended.
Okay.
Okay. Puri
Ma'am, then
Sharma,
others.
Kalia, Puri Sharma, Patania is for physical. Kalia is for Puri Sharma and Kalia is for inorganic.
Okay,
Both
ma'am.
are pillow sized textbooks.
Okay, that's very.
Yeah,
Okay, ma'am.
something
Others,
I always carry around. Okay. Jerry March, another pillow, 2 pillows of these 2 things. JD Lee is a handy book. Okay.
Ma'am, are those like small books that you're saying, ma'am, or big ones?
Just a moment.
Ma'am, you said pillow size, man. I couldn't get it.
This is the minimum size of one text.
Oh, okay.
That is for
Okay, ma'am.
undergraduation. Okay, not post graduation.
Okay, that is physical chemistry.
Yeah, physical chemistry by Puri Sharma and Patania.
Okay.
Yeah,
okay.
best text in the world. You find everything here. I don't know.
I'll take if I have the mindset to take chemistry, I'll probably use such books.
But I thought you had the mindset to take up physics better in the first.
I have already decided, ma'am. I'm taking up computer science, ma'am.
All right, not that I was thinking, because I remember initially you are not very much interested in chemistry.
Yes, ma'am. After coming to 12th only, I started
with chemistry.
Ma'am, actually, it was part of my mistake also. I already had a dislike towards chemistry, ma'am, because of which sometimes I didn't used to pay attention, maybe in school sometimes or classes, ma'am. Then I started to pay more attention and write down the things.
See, this interest in
inorganic part,
chemistry,
part,
especially the interest in chemistry, can be brought about by only by teachers. Okay, only teachers can create interest in chemistry. You
Yes,
cannot like chemistry if the teacher is not interestingly teaching you.
Okay.
Okay.
Ma'am, actually, yes, ma'am. Yeah, correct, very correct, ma'am.
That is one truth. For mathematics, also same thing goes.
Mathematics, I kind of have an inherent interest. Even if the teacher is not like they're not explaining something, I'll just go on the net.
It is there in your blood, means it will automatically come. Yeah, the blood thing works for me too, because my mother is also from mathematics background. Even my grandmother at this age of 90 now itself, she calculates three digit number into 3-digit number easily. From one end, she will start answering. Okay, without calculators. I don't know how, but I have that inherent interest in me also.
That's nice.
Yeah, but in chemistry, this all has helped me, but I am totally into chemistry. Okay.
Actually, speaking about me, ma'am, chemistry is not like, it's not my cup of tea in general, ma'am. But for the exam, I can manage it somehow, ma'am. And because for that, although like your like the teachers are helping, ma'am, you're helping, ma'am. That I still have a dislike towards chemistry, ma'am. That's the thing.
See, dislike and an interest is different.
I mean, in the sense,
you
dislike,
are asking a question means you are interested to gain knowledge. That is an interest you have in the subject. Dislike means you don't want to follow it up to that, and that's all.
Yes,
that doesn't matter. That doesn't matter, because your career interest is something you have already fixed. Otherwise, you won't be sitting here. Okay. So
I was about to say that it's although I'm going to take up computer science,
even I don't want you to follow chemistry. All right. The
No,
thing
I'm saying
is,
although I wanted to take computer science, from the exam I'm writing is for chemistry and physics, ma'am.
all right, okay.
That's my
That's still understandable. That I can see.
yeah.
I can understand it better because for my entrance examinations, it was like I was going for only mathematics and chemistry, nothing else.
Okay.
Okay. Finally, but I dropped the engineering seat and went for chemistry. That is my choice.
Okay, ma'am.
Okay. This is not because I didn't like engineering, because I fell in love with chemistry.
It's
That's the thing.
understandable. Because
Okay. Yeah.
it's not necessary everyone should do engineering.
No.
That's it.
No.
Ma'am, could you
And
say which all exams you have attempted when you were doing your graduation, ma'am, before and
he
after?
sat before this what you call ICAR examination. There was an ISAT exam for this ISRO kind of things. Okay,
Okay,
ISAT
ma'am.
was there. Yeah, ISAT was there. Then ICAR exam was there. KVPY exam was there, but I couldn't attempt it. KEEM, Kerala Engineering and Medical Entrance Examination. Kerala Engineering Examination is still happening. Medical Examination clubbed into NEET. Okay, Joint Entrance Examination. At that time, Joint Entrance Examination plus AIEEE was there. Yes, AIEEE also I attempted. AIEEE was very easy. JEE was a what you call, you cannot touch any question at all. At that time, it was like that. Now it is at least you can look into the question and not faint. Okay.
Was it so hard, ma'am?
It was so hard. The level of prelims itself was the level of higher mains. Okay. You have this main, sometimes very tough questions are there somewhere, isn't it?
Okay.
Not like that. Most of the questions will be in that pattern. It was very difficult. Maybe that is the way I was looking at the exam also. I don't know. Then there was this chance, like Tamil Nadu had an entrance examination separately for engineering.
Ma'am, I've heard about TANSET, ISAR, and one more thing you mentioned now.
ISAT, AIEEE,
AIEEE, I have
KEAM,
done.
KEAM, that is KVPY.
Not KVPY, that's still there, no, ma'am. So I have
yes.
heard. Not KEAM or something.
Kerala Engineering Medical. Then what did I say? ISAT was there.
Not
ICAR was there. Okay. That's it. That's the most.
So you gave like a couple of examinations, ma'am.
Mostly, yeah. AIEEE I wrote, JEE I wrote, then Kerala Engineering Medical Examination. Medical I didn't attempt, only engineering I did.
So
Then,
right now, other than JEE, what could be some more competitive exams that just I can attempt? And
KVPY. KVPY is a hardcore examination.
I heard that would contain biology, ma'am. So I had already ruled it out.
No. You can select mathematics over biology, not a problem.
Is it?
Yes.
Is it like almost like JEE?
Concept based, very tough competitive examination, KVPY. Okay. You will be into hardcore of the chapter.
Okay.
See, JEE is concept based application level question. This is concept based, what do you call, critical type of questions.
Okay.
You have to think logically.
But the question levels are also that much
tough, really tough, tougher than JEE. I would tell. Yes.
Okay, ma'am.
JEE advanced level minimum.
Recently, I also got a message from GURUJEE number that there's an international mathematical Olympiad and physics Olympiad is there now. For that qualifier, like kind of like for selecting the team or qualifier Olympiads, notice for that had come on.
Yeah.
So I was thinking, like, would that be in the line of what I'm studying for JEE, or would that like be digressed?
I haven't been searching about that more. I will inquire and tell you. Okay.
Sure,
and also,
because if
I think I want you to contact Sajid sir directly, because he will be having a pretty good idea about it, because all this time he was preparing students for this particular examination. Okay, he has that experience.
You mean JEE or
Olympiad, JEE, whatever questions, inquiries you are having, you can directly give it to Sajid sir. He will answer to you in a better way.
Okay, sure.
Okay.
Thanks a lot, ma'am.
Right.
Thank you very much.
Okay, thank you. Good night.
Good night, ma'am. Good night.
Good night. You have visitors, it seems.
I know, they're actually staying over for like 2 weeks, ma'am. My grandparents.
Yeah, good.
So, yes.
That is kind of like a support for you. Okay.
Yes. Okay. Thank you, ma'am.
Thank you.
Good night.